Have you ever been casually engineering a robot to suddenly have it explode in your face? Then this video is for you. Today's video is going to be about doing a simple risk analysis and how it can help ensure project success. What is risk analysis? It is the identification and classification of risks so they can more easily be mitigated. Risk analysis can be as simple as finding risks and ways to avoid them. Let's get started.
So this is the HOQ that I did in a previous video. And in this video, I'm going to add a risk analysis to the HOQ. This makes it so that when you are doing a project, you can put the risks in so that you can avoid those so you don't have a failed project. In this risk analysis, I'm not going to make it from scratch. There's actually a little bit of Excel coding that I needed to do to get this, but I will explain the code and I'll show all of the equations up here so that you can see the equations and you can build it for yourself. So with this risk analysis, I've only built it out to have 4 events, which would go on the top. So event 1, event 2, event 3, and event 4. For each event, I give a risk score from 1 to 10, depending on how risky the event is. If the risk were to occur, how catastrophic would it be for the project? In this case, I'm just going to do something simple. I'm going to do 2, 4, 6, 8, with 1 being the smallest, 10 being the highest. And then right here on the probability, this is just an expert opinion of how likely it is for that event to occur during the course of the project. For event 1, I'm going to do something simple again, 0.2, 0.4, 0.6, and 0.8, which if you are doing this project, a catastrophic event with a 0.8 or an 80% chance of occurring, that would really need some risk mitigation. And then here I do the cost of the event. So this would kind of mirror the risk score. So I'll do, again, 20, 40, 60, and 80. Those are all going to be in dollars. And then this right here, so this risk level does a quick calculation to give you the risk times the probability to tell you how close you are to having a very, very risky project. If all of these were 10, so let's just do that really quick, you'd get a risk score of 100%, but because they aren't equally likely to occur, your total risk is only 50%. So 50%, it's more likely that you'd only get 50% of the events happening than it is not. Ideally, you'd like to minimize the total risk level and the risk score, which is where you would go and put risk mitigation strategies down here, probably in another portion of the table. Just to make sure that you have a strategy to mitigate all of these risks. And then in this section of the table, we have likely events. And that is the best case scenario, which means that none of the adverse events happen. And then the worst case scenario, where all of the adverse events happen. And then the most likely, that's where you'd use your expert opinion. I'm going to say that most likely the first 2 low tier events aren't going to happen, but the 2 higher events are most likely going to happen. So I would know from this that most likely I'll be spending $140 extra on this project. And in the worst case scenario, I'd be spending $200 extra on this project. For the equations that are in this costs section right here, all I am doing is if this cell contains a plus, it adds the money cost of the event to the next cost of the event if it's a plus. So as you can see, all of them are minuses here, and you end up with a cost of 0. for this cell, I am summing all of the total events, and then I am multiplying that by the total number, the total possible number of risk. So if with 4 events, that's 10 times 4, so that's 40. So it would be 2 plus 4 plus 6 plus 8 divided by 40, put as a percentage. And that tells you how much total risk this project is going to have. For the total risk score, that tells you if all the events were guaranteed to happen. You would have the sum of everything, and then you also have, again, just the total number of events. So that would be, in this case, it's 40 out of 40. Which gives us a risk score of 100%. This right here, probability of nothing. So that just takes the inverse of all of these, multiplies it all together to give you the probability that nothing will occur. So in this case, it's 0.8 times 0.6 times 0.4 times 0.2. And in basic probability, when you multiply each event together, it gives you the probability that every event is going to occur. So in this case, you have a 3.84% of no adverse events occurring. So the next time I do a project, I'm going to be implementing the HOQ to design the project, and then I'm also going to be doing a risk analysis to make sure that nothing will go wrong in that project, or if there are things that are going to go wrong in that project, I will have ways to mitigate those responses.